Question number 4. The probability that a person completes a particular task is less than 15 minutes is 0.4. Jeffrey selects 20 people at random and asks them to complete the task. The random variable x represents the number of people who complete the task in less than 15 minutes. Probability of x in between 5 and 8. Anyway, it's a clear case of binomial distribution. Yes, so we have a random variable x. So how this random variable x is distributed? So we will first of all define x. What is x? Number of people who complete the task in less than 15 minutes. And how this x is distributed? Binomially distributed. We will be interviewing Jeffrey selecting 20 people, correct? Therefore, 20, what is the probability of doing this thing in less than 15 minutes? That is 0.4. So x binomially distributed with a 20, 0.4. Therefore, probability of x in between 5 and 8 could be calculated by finding it from, it's not x less than or equal to 8, it's x less than 8. X less than 8. So that is equal to probability of x less than 8 minus probability of x less than 5. So that means probability of x less than or equal to 7 minus probability of x less than or equal to 4. So you go to the table, cumulative binomial distribution table. Then for p-value 0.4 and n value 20, look into the value for 7 as well as 4. And what all values we will get? 0.4159 minus 0.0510. And if you're doing so, we will get 0.3649 as our answer. 0.3649 is the required answer. Move to the second part of this question. Mia takes a random sample of 140. Using a normal approximation, the probability that fewer than n of these 140 people complete the task in less than 15 minutes is 0.023924 decimal places. Find the value of n. So what we should do? It is a normal approximation. That means discrete random variable distribution variable. That is now we are approximating as a continuous random variable distribution. Correct? So definitely we should apply what? The error correction. I mean the interval correction. And also in binomial distribution, this is now completely changing to normal distribution. So what will be the mean? What is the equation for mean? Mean is n into p. The mean is n times p. How many people altogether? 140. So 140 multiplied by the probability that it is less than 15 minutes to the 0.4. So that will give us 56. And then what is the standard deviation? Not standard deviation, I mean the variance equation is npq. So that is equal to 140 multiplied by 0.4 multiplied by 0.6. And if you are substituting these values, what we will get? 140 multiplied by 0.4 multiplied by 0.6. That is 33.6. How we got that 0.6? Q is actually 1 minus p. 1 minus 0.4. So the variance is 33.6. So here we have a variable y, because that is completely changed to normal distribution. So y normally distributed with the mean 56 and the variance 33.6. Now, it is given in our question that y probability of y that is less than probability of y less than n is equal to probability of y less than n is equal to 0.0239. And we know that in normal distribution, everything we will be converting it to standard normal distribution variable. So how will you convert this standard normal distribution variable? So that means the Z value we will be calculating based on the equation n minus mu by sigma. So n minus 56 divided by n minus 56 divided by 33.6, the square root of that. But this is actually the case when we are directly applying this formula for a normal distribution. But this is actually what? This is actually a normal approximation. So we should apply the interval correction, the continuous interval correction. So how will you answer this? Z is equal to n minus 0.5, because this is how we are applying the continuity correction, n minus 0.5 minus 56 divided by square root of 33.6, and probability of Z less than this is 0.0239. Now, this is the normal distribution curve, and this is actually the standard normal distribution curve, and this is our the corresponding Z value, such that this area is 0.0239. Obviously, this is a negative value. This is actually a negative value. So our table values are actually for the positive values. So this value, I'm just keeping it as say Z1. Say Z1. So there will be, by the symmetry, there will be another Z1 such that this area is also 0.0239. So the probability of Z less than Z1 is exactly equal to, so here this is actually minus Z1. This is positive Z1. So probability of Z less than minus Z1 is exactly equal to probability of Z greater than positive Z1. And that is exactly equal to 1 minus probability of Z less than positive Z1. So 1 minus probability of Z less than Z1 is our 0.0239. Therefore, probability of Z less than Z1 is 1 minus 0.0239. What is that value? 1 minus 0.0239. 1 minus 0.0239. So that is 0.9761. So probability of Z less than Z1 is 0.9761. And then you go to the table. And for what value of Z1 that is happening? So Z1, we will get it as positive 1.98. But actually Z1 is our what? Negative Z1, right? So the negative Z1 is n minus 0.5 minus 56 divided by square root of 33.6. Since if you are solving this equation, we will get n as 45. So if you are solving this equation, because the Z1 value is 1.98. So if you're solving this value, what happens if you're in place of Z1, if you are keeping 1.98, that is minus 1.98 is equal to n minus 0.5 minus 56 by square root of 33.6, and then you cross multiply, and if you are making n the subject, you will get n is equal to 45. So that is the idea about this question.